Yes, students. Thank you for the confirmation. So we will begin the topic for today. Just I'm sharing my screen. Yes, it is shared. Okay, good. So a warm good morning once again. So today we will be looking about version 3. That is, we are continuing the SNMP version 3. Yesterday we saw SNMP version 3. What are the features we have? So we have three features. We have dispatch unit, and then we have message processing unit, and then we have this security feature which is enhanced in SNMP version 3. So next we saw what is the architecture and the applications. That is the things that apply on or rely on the SNMP. So in architecture we saw SNMP engine, and then SNMP engine has got four components. So we saw them, and then we saw the applications. So that is your generator, that is message generator, notification generator, all those things, and proxy also. So that was about SNMP version 3 that we saw today. And today we will be seeing about SNMP version 3 MIB security features. That with that MIB security feature, SNMP version 3 gets completed. Then the next topic will be remote monitoring. So we'll be seeing about what is remote monitoring and how MIB and SMI are for the remote monitoring system. So by tomorrow we'll be completing your fourth unit. And so this is your SNMP version 3 MIB. So this SNMP modules, you can see that it is further subdivided. So we have these seven further modules that comes under the SNMP modules. So the first module is SNMP framework MIB. So the object ID for it is 10. So every module will have the object ID, right? So whether it is an object, whether it is a device, or whether it is any kind of modules that we have, everything comes with an object identifier. So SNMP framework MIB is used to monitor or manage the SNMP architecture that we have, version 3 architecture. So the work of framework MIB is SNMP framework MIB does the work of managing your architecture. So next we have SNMP, that is your message processing MIB. So we saw that your messages, once it is generated, it goes on to the dispatcher. Your dispatcher unit will dispatch it to the corresponding message processor model, that is MPM or message processing subsystem. So from that it goes on to your security model. So your security model will check whether you have the access control, then you have the authentication. So after that, it just gives your response from the security model. So likewise, the MPD MIB, that is, it is used for your message processing. And then the third one is your SNMP target MIB. So this target MIB is further classified, or it is grouped as SNMP target object. Okay, target MIB is further grouped as SNMP target objects, where we have this target address table and target parameters table. So we use these target address table and target parameters table when we are sending messages between the agent and your manager. So every entry in the target address table and target parameter table will have its corresponding object identifier. So that identifier is listed here. So this is your target address entry, then it is the corresponding object identifier, and the meaning, it specifies the row in the target address table. So you have these kinds of entries that we have, and the corresponding object identifier for them, and what is the meaning of them. So if you see the SNMP target address entry count, so this gives you the count of the number of entries that we have. Okay, how many entries we have in that table. So that is given by your target um, entry count. So this gives you, so this is the object identifier, and it gives the number of entries. Okay, so these kinds of things are used when we transfer the messages through the network from the manager or to the agent. So every object will have its ID. And then this is about your target address table. And the next one is target parameters table. So these are the entity and this is the object identifier and this is the description. So parameter target param entry will contain the set of SNMP target information. So these will be, as usual, will be used in network transfer between the manager and the agent. So this is the table. And then the next MIB is your notification MIB. So notification is used when you have a trap message or when you have an authentication fail. So some kind of notification message that we have in the network. So these kind of notifications are given by the agent. Okay, so this is generated by the agent. So that's it about the SNMP version 3 MIB. So this is the diagram which says what are the different modules that we have. So we saw what are the use of these. There is proxy, the same. Okay, so proxy MIB is used for the conversion of your SNMP version 1 to SNMP version 3 or non-SNMP to an SNMP version. So this is about SNMP version 3 MIB. And the next one is the security feature. So in your MIB, so we have seen those 7 models. So next, why do we need this security concept? So as we saw yesterday, security is the enhancement that we have in version 3 of the SNMP. So version 2 also had security features, but it was enhanced in version 3. So how we provide security? So as I told you, we provide end-to-end encryption. That is the data, whatever it is transferred, the messages and the responses between the manager and the agent is encrypted. So the example that I gave you yesterday, that WhatsApp is end-to-end encrypted. So whatever messages you send, or even if it is a kind of a voice call or whether it is a video call, it is encrypted. So it is encrypted such that no one else can tamper what you are speaking with the other person. Only you and the end person, end user, will be able to understand what is being communicated. So same wise, SNMP version 3 also provides security features. So how does it provide? So this uses the encryption algorithms that we have already, which is MD5 and the SHA algorithm. So this SHA algorithm and MD5 are the algorithms that help us to provide authentication. So it helps to provide whether that particular manager is capable of accessing the particular agent, whether the agent is capable of sending a response back. So those kind of authentication, that is read only, read write. So if we don't have permission for writing, then we will not be able to do that. So those kind of authentication is given by the MD5 and the SHA algorithm. And in order to encrypt the data, okay, in order to encrypt whatever messages that we are using, then for that we use cipher blockchaining mode. So this is used for encryption, and for authentication we are using MD5 and the SHA algorithm. So these algorithms are basic algorithms for any encryption and authentication techniques that we have. So we are not going to deal with how this algorithm works. So we are not going to look upon that. So we'll just know what algorithms they are using. So to provide security, SNMP version 3 uses MD5 and the SHA algorithm to provide authentication, and cipher blockchaining for, that is your DES algorithm, data encryption standard. So DES algorithm is used for doing the encryption. So how, just I'll give you a basic overview how this encryption happens. So what we do is we take all the data, blocks of data. So data are represented in blocks, that is 8 bits. So these data will be having key. Okay, the key can be either a primary key, or that is, it can be a local key or it can be a global key. That is meaning the key will be known to the sender and the receiver, then it is a public key. If it is a private key, then it is known only to the, that is, if it is a public key, it is known by everyone. So if I want to open google.com, then google.com is open. Okay, anyone can just click on google.com and view or search for something. So if I go and log in using my Gmail, then I am able to access it. Only I know the password of my mail ID. So that is what is private key. So private key is known only to the user. It can be the sender or it to the that is to the receiver. So only the receiver and the sender, source and destination would be only able to know what is the key. So I will know what is my mail password. Likewise, the Google server, Gmail server will know what is my password and it will validate it and give access right for me to use my mail account. So that is what we have. So we have two keys. One is public key and another one is private key. So we use these keys and then the algorithm does the encryption technique. So when I type something on the network, it doesn't go as how I type. So if I type hello students, so on the network it doesn't go as hello students. So it encrypted, that is, you can change the order of the characters. So it can be shuffled. That is, I can shuffle by two characters. So I'll get some content, right? So that content gets transferred on your network. On the destination side, that on your receiver side, again it is reshuffled, and then you get your original content. So this is how the encryption works. So this is just an overview of how encryption works. So we have two keys. One is primary, other is public key, and the second one is private key. And you have many algorithms that allows you to do encryption standard. So this security features, security algorithms that we have, you will be studying in your seventh semester. You have a subject cryptography and network security. So on that subject, we'll be studying about these algorithms. So these algorithms are just for you to know, understand now. I just told you what are these algorithms are. So for authentication, we are using MD5 and SHA. And for encrypting your data, we are using DS, that is data encryption standard. So what are the kinds of threats that we can have in our network? So this is a general threat. It is not specific only to SNMP. So in generally in any network, you can have these four kinds of threat. Threat are meaning that they are a danger for the network. So first one is modification of the information. So that is if I am sending you, for example, you are viewing your CGPA from the Anna University server. Okay, you are going to view your result. Suppose if you have cleared your all the six subjects and your CGPA is assumed that it is 9 CGPA and sorry 9 GPA, but when you are viewing it on the server, if someone is tampering your result and making you fail in two subjects, then that is called as modification of information. So a third party will tamper your data and you will not be able to view what is the original message. So that is called modification of information. That is, your original message is changed. So this is done by a third party, a hacker. So you have ethical hacking also. So when something happens like this, when someone is hacking your system, we have ethical hackers who will be able to cope up with it. And in some situation, like the government will have to do ethical hacking so that it keeps its country safe. So those kinds of things are happening, and we are viewing them also in day-to-day life. So modification of information is your data is tampered by a third party. So next thread that we have is masquerade. So what this thread will do is this kind of thread happens when I am the owner. Okay, assume that I am a person who's gonna use my Gmail account. But what happens is by suppose my email ID and my password is known by a third person. Okay, so a third person is opening my Gmail account and is sending mail to some contacts that I have in my mail ID. Okay, for example, assume that it is sending a mail to 2018.csce, your group mail ID. But I am not the person who is sending the mail. So someone else who knows my username and my password, he is trying to log into my mail ID and he is sending mail to contact that I have in the mail account. So that is called as masquerade. So you are, that is, the person is assumed to be a original or authenticated user, but he is not so. So that kind of threat can also happen when your username and your password is known to a third party. So the third one is message stream modification. So what this message stream modification threat is, for example, your SNMP works with UDP protocol, as I've told you earlier. So UDP protocol is connectionless protocol, you know that, right? So TCP is connection oriented and UDP is connectionless. So if it is connectionless, if you are transferring your data through your network, it is transferred as packets. Okay, you have small packets. Your data is split down into small packets, and these packets are transferred through the network. So those things you would be knowing it by studying the subject computer networks. In your networks, you would know that your data is transferred in terms of packets. So when I send some information, so on the network, it is transferred as packets, and on the receiver side, okay, on your destination, these packets are rearranged, okay, so they can come in any order, so they can be received in any order. So once these packets are received at the destination side, it is rearranged such that the original meaning of that message remains the same. Suppose if I send a message that I will meet you by 4 p.m. Okay, if some this message is shuffled, okay, so I'll meet you by 4 p.m. It is just changed as like 4 p.m. I'll meet you something. Understand that you don't have a meaning from that message. If I shuffle it, uh, it doesn't have a meaning, or if the content of the message itself changes, so then that is called as message stream modification. So that is also one kind of threat, and this can be done by a third party. So message stream modification is changing the order or reshuffling the message packets that is received at the destination such that the meaning of the message changes. Okay, so that is message stream modification. And the fourth threat is disclosure. So disclosure, that is what happens is the data is not changed, like how we do in modification of information and the message stream. So that data is not changed. Instead, what we call this is eavesdropping. Okay, for example, someone is, if a person is beside me when I'm typing my password. So if he is able to view my keyboard and he understands what my password is, then that is called as eavesdropping. That is, a person is viewing my message. He's not going to tamper anything. He's not going to change the password. So he is able to view my passwords. That is what is called as disclosure. So your data is exposed. So these are the different threats we have. So we have two more threats which was treated as non-threats. That is, they don't do much damage to the system. So these four kinds of threats, if they happen, then you have a damage to your system. Your whole network can be crashed. So modification of information, masquerade, message stream modification, and disclosure are the four threats we have, the major threats. So this is how it is represented as a diagram. So you have an management entity A and entity B, that is A and B. So A is sender and B is the receiver. So this modification of information, masquerade, and the message stream modification will change the message. Okay, will change the message. And disclosure, that is just you are able to view the message, so nothing is tampered onto your message. So this is what it is represented. So these are the major security threats that we have. So next we have two non-threats. That is, they do, if even if this threat happens, you don't have much damage to your system. So those two are denial of service and traffic analysis. So what DOS attack is, the denial of service, in short, it is called as DOS attack. So what this DOS attack will do is, server is capable, this happens at the server end. So your server is capable of processing the request that it receives from the client, and it is giving you the response, right? So if there are n numbers of requests, so your server is capable of processing it, and it will give you the answer that is required, that is your response. What I can do is, if I am a hacker, I will make the server down by giving infinite number of requests. Okay, I'll be giving it infinite number of requests where the server will not be able to cope up with that many number of requests at a time. Assume that a server is capable of processing 1,000 requests at a time, but as a hacker, they will be giving you 10,000 requests at a time. So a server which is capable of providing only 10, processing only 10,000 requests is receiving, a server which is capable of processing only 1,000 requests, it is receiving 10,000 requests. So what happens? Your server will crash. Okay, so you are denying a service. So a server is not able to process the request, and it stops receiving request from the client. So a client is not able to receive some response from the server. So this is called as DOS attack. So that if this attack happens, your server will crash, but nothing happens to your data. So this is treated as a non-threat. And then the second one is traffic analysis by unauthorized user. So a hacker can identify what kind of traffic it happens, so that he can do some kind of modification such that this DOS attack comes in. So he will be looking what is the number of requests that the server is doing at particular time at 10 a.m. So what is the number of requests it is receiving at 12 a.m. What is the number of requests it is receiving? So we can assume that at night time we don't have much request that comes to the server. So, but during the daytime, you will be using the server very frequently. So, this kind of analysis he can do by monitoring your network traffic. So, that doesn't make much damage to your data, but this can be a kind of threat which leads to a damage in the near future. So, these are the other two threats we have, that is denial of service and traffic analysis by unauthorized user. So yesterday I was attending a webinar, and then I just came to know of a thing which happened recently. I just share with you since the topic is related with security. So we have Sony Musics, right? So this Sony Music, it was I think the movie name was Interview, if I'm not wrong. So that was the movie name which was supposed to be released in North Korea, but I don't know what was the reason why people in there's the government of North Korea did not want that movie to be released in their country. They gave intimation to the company, but still the company was abandoned. That is, it was very much it very much wanted that movie to be released in the North Korea. So what North Korean government did is they hired hackers. So we have how they hired hacker and how they deleted that movie from the Sony server was very much shocking for me to listen it. So what they did is they hacked a person who was working in that company. So what they did is using that is the seminar that I was attending was on AngularJS. So that AngularJS they used it as a code to do hacking. That is, they just gave a script which runs on the person. So what they did is the hacker created a script, okay, an AngularJS script. So what they did is this a person who is working in Sony, he was very much confident and working with the social network. Okay, whatever happens, he used to post it in Facebook. So I'm here, I'm there, I'm doing this today, I'm this doing that today. So just they knew the person by looking at his profile in Facebook, and then once this person was using open Wi-Fi. Okay, we have a tendency to use the open Wi-Fi, that is free Wi-Fi, wherever we go and have it. So you go to McDonald's, you use the free Wi-Fi that you have. So this person was using the Wi-Fi that is available free, and what they did is they just sent a script onto his mobile, okay, by using the social media. So they just sent a script. So that script, when he connected his mobile onto the company's free Wi-Fi, okay, so that company's free Wi-Fi, they were able to access the network. So they were able to access the network of that company, and they hacked the server with this free Wi-Fi, the script which was already in his mobile, and they deleted the movie that was not supposed to be released in North Korea. So this is just a thing which happened, and I got to know this yesterday. I'm just sharing with you. So these kind of threats are happening. So we need to be more vigilance. So we should not go into spray. So this is the next topic is the security model. So as this is the diagram which we saw yesterday, right? Command generator will generate messages like get request, get next request, and so on. So this goes on to the dispatcher. So dispatcher will move it to the message processing model. Then this goes on to the security model, which provides the authentication. So once this authentication is done, you get the response through the network from the agent. So that is the work of a security model. So what we have is, so these kinds of security services are provided. So when this, excuse me, so when this message processing model and your security model communicate, so what happens between these two? So you have these kind of security subsystem that is available in your security model. So the modules are authentication module, privacy module, and timeliness module. So these modules will help to provide the authentication and security. So we will be looking on each of these models. So this happens when your message processing model and your security model communicate with each other. So in this diagram, we see that message processing model and your security model will communicate to provide the authentication, right? So how does it happen internally? So first we will be looking about the authentication module. So what happens in authentication module is you provide authentication. You have SNMP engine which provides two kind of authentication. That is, you have two kinds of SNMP engine. One is SNMP authentication engine, and the second one is SNMP non-authentication engine. So when you have a data transfer between a manager and the agent, so whichever messages comes from the manager, okay, like get request, get bulk request, get next request, inform request, all those messages comes from the manager, right? So those kind of requests which comes from the manager will go to the SNMP authenticator engine. So your agent is just the response. So whatever data that it is able to receive, it will check for the integrity of the data. So data integrity meaning that the data which is transferred should be the same. It shouldn't be tampered by a third party. For example, if I am sending you a message that submit your assignment by 12 p.m. today, so I'm sending that 12 p.m. today. So if you, when you are receiving the message, if you are receiving the message as submit the assignment by tomorrow 12 p.m., so then that is the change in the data. So that is data integrity. So data integrity checks for the correctness of your data. So whatever sent at the server side, at that is your source, the same should be received in the destination. So authentication module does your data integrity, that is, it checks for your data, and it also checks for the authentication. Okay, authentication of the origin of the message. If I am sending a message, okay, so what this authenticator engine, that is, I told that your SNMP contains two engines, right? So what this authentication engine will do that it will append a unique ID that is associated with every device. So whenever you send some data, so it will have this unique ID appended to the data. So that will tell you whether the message that you receive is from the original person or not. Suppose if it is tampered in between, then you can check for the ID of that particular data. Okay, origin ID of that particular data. If it is changed, then it means that you are not getting the data from the original person. That is masquerade. So the message that you have received is not from the authenticated user. So your authentication module provides data integrity and data origin authentication. So next one is privacy module. So privacy module will safeguard the data. That is, it provides confidentiality. So data is not, that is, it provides meaning, that is, it provides techniques such that the data doesn't get changed. So what kind of techniques we are using is encryption technique. So it provides encryption technique such that data doesn't get changed. So this privacy module will provide data confidentiality. That is, the data shouldn't be changed. And next one is timeliness module. So what this module will do is it will set a window timing. Okay, it will set, that is, you have a particular time in which your message should be transferred. That is, if I'm starting a data transfer at 9 a.m., assume that I'm transferring a data at 9 a.m., it will have a window time. Okay, that is, it should, the message should reach the destination in a particular time itself. For example, assume that it should reach within 100 seconds or 200 seconds. So if it is not reaching the within the 200 seconds, then I can assume that there is some kind of modification being done about my data. That is, if the packets are rearranged. Okay, so the hacker will have some time to do the rearranging, right? So that timing will exceed my window time that is set already. So that is given by the timeliness module. So it provides a window, okay, a time window within which your data should reach the particular destination. So that is about your timeliness module. So authentication module provides data integrity, that is correctness of the data, and data origin authentication. So origin authentication is done by appending a unique ID to the message that is getting transferred from the particular source. And the privacy module will provide data confidentiality. That is, it provides encryption so that your data doesn't get changed. So timeliness module will provide a window time. So your data should reach the destination within a particular time seconds. So this is your authoritative SNMP engine. So I told you that your SNMP engine is two types. One is authoritative and one is non-authoritative. So if your SNMP manager is sending messages like get request so on, if the message is coming from the manager, then your authoritative engine will be your manager and the non-authoritative engine will be your agent. Suppose if the message is some kind of notification, so which comes from the agent, right? So then your agent becomes authoritative engine and your manager becomes non-authoritative engine. So the manager and agent will change their position. So security, or that is, you provide data integrity and data origin authentication. That is we saw now. So next, to provide privacy, so data confidentiality is to be enhanced. That is, the data shouldn't be available or disclosed to unauthorized users, entities, or processes. So to do that, we have this encryption technique. So once in the, that is, when I am sending a message, so it is encrypted at my side. That is, at the source side, it is encrypted and it is transferred over the network. At the receiver side, at the destination, it is decrypted. So decrypted in the meaning it is changed to the original message. So encryption and decryption are the two things that we do in order to provide data confidentiality. And the next one, as I told you, it is timeliness. So the recommended value for the window time in SNMP version 3, it is 150 seconds. So I told you that minimum the time, that is the maximum time in which your data should reach the destination is 150 seconds. That is given in SNMP version 3. So your SNMP engine maintains three objects. Okay, so these are the three objects it maintains such that this timeliness of the message is maintained. So one is SNMP engine ID. So you can have a unique ID that is given for the SNMP engine. So SNMP engine consists of four components that we saw yesterday, right? A dispatcher, message processing model, and then authentication model and your security model. So these are four components we have. So every SNMP engine will have a unique ID, object identifier. Next is the second object is engine boot. So engine boot is nothing but the time in which your SNMP engine is either booting or rebooting. Okay, suppose if I am booting my laptop, okay, so at which time did I switch it on? So that time is maintained. So in the object called as SNMP engine boot. The third one is SNMP engine time. That is the time from which your engine is still running from either it was booted or it was rebooted. For example, I switched on my laptop at 8 a.m. today morning. So my engine boot time will be 8 a.m. So I started my laptop, I booted my OS at 8 a.m. So next SNMP engine time, so now the time is 10:10. So it is still running for 2 hours and 10 minutes. So that is engine time. So how much time your system engine is still running from when it started, that is when it booted and or when it was rebooted. For example, I started my laptop at 8 a.m. But due to some issues, I had to restart it or I had to switch it off and switch it on. So after that rebooting time, what is the time in which your laptop is still running? So it is running for 1 hour and 10 minutes, something like that. So that is your SNMP engine time. So these are the three objects that your SNMP engine maintains. So next is remote monitoring. So with this, whatever we see till this, your SNMP version 3 is completed. So in SNMP version 3, we saw what are the features in SNMP version 3 and what are the different, what is the architecture it follows and what are the applications. Then we saw the MIB and we saw the security feature that your SNMP version 3 is giving. So just 2-3 slides, I'll complete today's topic. So next one is remote monitoring. So what is remote monitoring? So if that is SNMP, what it does, it monitors all your data and all the devices that we have in the network. So how it monitors with the help of manager and agent. So manager and agent are nothing but softwares which run on the particular devices such that the network is monitored. So what is the system uptime? What is the running time, when the system what started, who is the vendor, what is the version it is using, what is the license it is using, what is the remote monitoring. Local monitoring, or I consider a LAN, so then that I can consider it as remote monitoring. We have a system admin, right? So a LAN systems that are connected will be connected to the local server. So that local server system admin will be able to view what you are viewing of. So what kind of data you are transferring, what you are searching on the network, or what kind of websites you are viewing on your internet. So those kind of things are monitored if it is within the network. Okay, then it becomes a local remote monitoring. If it is global, okay, if someone who is in US is monitoring my particular network, then it becomes a global remote monitoring. So how it is done is we have two different ways. So one is a network monitoring system. Okay, you will have NMS, and the second one is you will have a probe. So network monitoring system is like a server. Okay, you have a server which is monitoring, or you can have call it as a manager. So this manager is monitoring all the components, all the devices that we have on the network. So probe is nothing but it contains two components. One is the physical object, that is the device is itself. So this device is being monitored by a processor. So a probe will have two things. One is the device itself, that is the physical device. and the second one is a processor. So this processor will be able to monitor what happens, what is the data that is getting transferred. It will be able to monitor everything regarding that particular network. So you can either have a network monitoring system like what we saw in SNMP. So simple network protocol, right? So that kind of a thing you can have, or you can have it as a probe. So in a probe, you will have a processor. So that processor will be able to monitor your network. So next, this is a diagram. Okay, here you have a LAN. Okay, you have a local network. So in this local network, you have the network monitoring system. So this NMS will be able to monitor this local network. So here on a token ring network, okay, this token ring network is monitored by a probe. So a token ring probe. So this probe will have a processor. So that processor will be able to monitor this token ring network. So like this, if we have FTT probe, so where this is monitored by a router. So these are the different kinds of network monitoring you can have. So next is just a simple SMI and MIB. So how SMI and MIB is done in remote monitoring, that we will be looking in the second, that is the next class, just an introduction. So this network monitoring system is also is to be monitored like how we have ASN for the SNMP. So for SNMP, we have this ASN which gives you the syntax and semantics. So how the data is transferred, what kind of syntax it follows, and when you are transferring it, what kind of encoding is done such that the data doesn't get tampered. So likewise, your network monitoring also follows the ASN syntax to do the transferring of data. Then you have three different stages in which your network monitoring was used. So first, network monitoring MIB, which we call it as remote monitoring 1, was developed for the Ethernet LAN in 1991. So later on, it was of no use. So it was absolute meaning that it is of no use and it is not being used. So after 1995, it was not used. So we have this token ring, which is an extension for your remote monitoring 1, which was developed in 1993. So first was remote monitoring version 1, then we had extension for remote monitoring 1. So these remote monitoring 1 was not capable of working after the OSI layer 2. Okay, till level 2, that is physical data link, only it was able to work with. So this was not able to work with the higher layers of the OSI model. So for that to be addressed upon, we have remote monitoring version 2, which works with all the layers from 3 to 7 in the OSI model. So we will be looking about the remote monitoring 1 and the remote monitoring 2 in the next class. So that's it for today. So these are the different modules that we have in remote monitoring 1. So these are the modules that are available in remote monitoring 1, and these are the modules that we have in remote monitoring 2. So this is under the MIB2. Okay, this comes under MIB2 module. So these modules will be looking upon tomorrow. So that's it for today. I'll just show you your syllabus, how much we have covered. So yesterday we started version 3, then we saw the features, and then we saw the architecture and the application. So today we saw what is MIB security. So what is MIB in version 3 and the security features. So we saw what is remote monitoring. So why we need remote monitoring. And then we saw just an introduction about the MIB. So we have to look upon the remote monitoring 1 and remote monitoring 2 tomorrow. So tomorrow I'll complete the 4th unit, and from Monday I'll be starting your 5th unit. So that's it for today. So thank you. If you have any doubts, you can ask me. Okay, then thank you, students. You can go for break.